John Englander is an oceanographer spanning many disciplines and areas of expertise. He is a global ocean explorer with personal experiences on expeditions under the polar ice cap, deep dives and research submarines, and visits to Greenland and Antarctica. His mission is to be a clear, objective voice on our changing climate and oceans. Mr. Englander's broad marine science background, coupled with dual majors in geology and economics, allows him to see the big picture on climate and look ahead to the large-scale financial and social impacts, particularly as they relate to sea level rise. High Tide on Main Street, Rising Sea Level and the Coming Coastal Crisis is his new book, and he'll tell us all about it now. So, John, welcome to Late Night in the Midlands. Pleasure to have you.
Thank you. Pleasure to be with you.
Well, I do thank you for taking time out to be with us tonight. Very important topic, no doubt about it. I thought maybe we could start out, tell us a little bit about your book and what's led up to you writing it, as if I have to ask. I mean, it's happening.
Sure, thank you. Let me put it in perspective, I guess. I started looking at sea level back 40 years ago, I hate to say, when I was in college. And I was fascinated that as the ice sheets came and went, what we call ice ages, and that's not in dispute at all, but that's something that I hadn't thought of, and hardly anybody else had except for specialists, is that as those ice sheets, 2 miles thick, came down over the northern hemisphere regularly in a natural cycle, that sea level went up and down 300 or 400 feet vertically as 10,000 feet of ice melted and then refroze every 100,000 years. And I thought that was amazing. The fact that we've had a fairly stable polar ice cap for 3 million years indicated that in our lifetimes nothing really would change. It was a very, very slow cycle. But then fast forward, of course, over the last decade or two, there have been increasing signs of warming, measurements of warming, and I started to realize that we were altering the big picture, the natural cycle of ice ages. But I couldn't put it all together. And I had lots of different insights into the ocean from thousands of dives and even under the polar ice cap and working with leading scientists, but there were just pieces that didn't quite fit together. So about 4 years ago, I began to research everything I could so that I could fully understand what were the natural cycles and where were we affecting it. And what did it mean with sea level rise? And the book, as you say, is the outcome. It fortuitously was published a week before Sandy hit Atlantic City. And it was the most fortuitous timing, terrible as that event was, because in Chapter 12, as I think you know, I picked a couple of dozen cities to describe what could happen. And I described that kind of storm hitting Atlantic City and why it would devastate New York to show some peculiar factors of geology and topography that very few people had looked at. And the fact that it happened a week after my book was published was just pretty incredible.
That is incredible. Now, do you think that the Northeast has less skeptics now on this whole climate change issue?
I think so. I don't know where you're based. Are you up in the Northeast?
I'm in the Southeast. I'm in South Carolina. So
okay.
On the East Coast, but no, I just got missed. We were lucky. It hit I think the corner of South Carolina, mostly went into North Carolina, so they got hit bad, but we didn't.
Yeah, I'm in Florida, and it was interesting. 2 days before it hit New York, or I guess a day and a half, it gave a good brush to Florida. They put enough sand over some of the main roads right along the coast to actually close some roads with the surf. But then it was only about a 30 or 40 mile an hour wind storm. By the time it hit New York, it was, I guess, 80 or 90 miles an hour and full Category 1. I think to answer your question that, yes, people in the Northeast are paying more attention, but they are all over the world, because the fact that you could have a 9.5-foot storm surge above normal tides and extreme tides, which is the what we had then was seasonal high tides, lunar high tides, that the fact that it could have that kind of a devastating effect because of certain factors, which is what I was describing in the book, has caught everybody's attention all over the world. I mean, who would have, people think of Miami or the Maldives or the Bahamas or places like that as vulnerable to sea level rise, or Bangladesh, but nobody had ever thought about New York City, which was the reason that I wrote about it. And it has been an attention getter for everybody, and whether you live in the Northeast or anywhere else, because as I point out, from Boston to Seattle to Vancouver to San Diego, to the Maldives, to Monaco, to Manila, to Shanghai, to Singapore, every coastal city in the world has vulnerability. And then there are surprising vulnerabilities that people would never think of, like New York City, like Washington, D.C., which is on a tidal river, like Sacramento, which appears to be far inland but is on the Sacramento River and has 1,300 miles of earthen levees, more earthen levees than are in New Orleans. And actually, Sacramento has more vulnerability to earthen levees collapsing than New Orleans. So that was the purpose, to describe these dozens of places, which are literally hundreds of places in the world that people don't think of. They just think about Miami, the Bahamas, the Maldives, Kiribati, Tuvalu, the places they hear about. But this problem is truly ubiquitous. It's universal, whatever you want to say. It's all over the world. And the fact is that after 6,000 years of stability, which is how long sea level has barely changed, and that means the shoreline's barely moved, that after 6,000 years of stability, that we're in a new era, that we've crossed over, and now we're resuming the period when sea level will go up and down hundreds of feet, in this case up hundreds of feet, and eventually, and that could be thousands of years, but we started a new era and a new direction after 6,000 years of stability, and that's what's hard to get our heads around, that for the first time in 6,000 years, sea level's moving, the shoreline's moving, and it's going to continue for at least 1,000 years. That's what's hard to get our heads around.
Well, that is hard to get our heads around. What I found amazing about Sandy was two big storm systems that combined. I mean, it's the kind of thing I've seen in movies. You just never. I mean, I assumed that one day it would get that bad, but I didn't think so soon. And we should probably be preparing to see a lot more of this, huh?
Absolutely. I mean, hurricanes, which of course what Sandy was, are driven by heat in the ocean. And if you think about it in climate or geologic terms, what a hurricane does is it moves excess heat from the tropics to the polar regions. It's driven by a heat differential, basically. And the oceans are 1.5 degrees Fahrenheit, 0.8 degrees Celsius, warmer than they were a century ago. And the rate of warming is accelerating. So with that extra heat stored in the oceans, and particularly in the surface layers, the top 700 meters, 2,000 feet, that heat is going to manifest itself in more stronger storms.
I see. Now, you believe, and I guess there's actually some scientific evidence to back it up, and I have no doubt that man is contributing, but you believe that man is what's putting the big impact on the change in the climate, correct?
Absolutely correct. And in fact, when I started writing this book, I used to say that man was accelerating climate change. As I did the research and put the case together and explain and show in a couple of simple diagrams, we've not actually changed or accelerated climate change or warming. We've changed the direction, and that's why we're in the new era. We have just finished, well, let me back up. 20,000 years ago was the last glacial maximum, which we call commonly an ice age. And, the kids' movies are about it, and they have some accuracy to them, the Ice Age 1, 2, 3, and 4. But nobody disputes that we had an ice age during which we had 2 miles of ice down as far as New Jersey in the United States, and equidistant in Europe and Asia. And those 2-mile thick ice sheets. Again, they melt. But when you go back to that last peak 20,000 years ago, 21,000 years ago, when that much water was locked up in the ice sheets, the sea level was down 390 feet straight down from where it is today.
Wow.
That's a 30-story building. Now that it rose as the ice melted over 14,000 years and got up to pretty much its current level 6,000 years ago. Well, here's what became clear once I put that all out in charts and did the timeline for myself, is it became a really aha case of two things. That after 20,000 years of rise, by the cycle of the last 5 million years, we would be about to enter the 80,000-year cooling phase when the ice sheets would begin growing and sea level would begin dropping until the next ice age 80,000 years from now, give or take. Instead, we're warming, and the glaciers are shrinking all over the world, and sea levels rising. So we haven't just accelerated the change, we've actually broken or altered the ice age cycle, which has been on Earth for about 5 million years as a natural cycle. And when you look at it that way, when you realize that there is a natural cycle, it's a 100,000-year ice age cycle forced by something called the Milankovitch cycle, that when you just step back, and again, I try not to use technical terms, but when you look at this 100,000-year cycle of ups and downs, and we're at the top of it in terms of sea level, and realize it should be starting down, and it's now going up, and it will go up for at least 1,000 years, you realize we haven't accelerated climate change. We've changed the direction. And the numbers are...
Oh, I was just going to say, in 1,000 years, that'd be a huge, huge increase in the sea level if it continues to rise for 1,000 years.
It depends upon the rate. And there's a lot of unknowns in it because we've never warmed this quickly. In 500 million years that we can go back and track, we've never warmed remotely close to the current rate of warming. So we really don't know how quickly the ice sheets are going to melt. I mean, that's absolutely true, that uncertainty. What we do know is that when all the ice sheets melt again, and that hasn't happened for 30 million years, that sea level will be 212 feet higher than it is now. But that's not going to happen likely for probably several thousand years. It takes a long time to melt 2 or 3 miles of ice, even with the heat we're applying.
Well, they have been melting rather quickly, according to a lot of the stuff that I've seen out there. It seems like I've seen an article not long ago that said Greenland had lost, a large percentage of their ice, and that it was like green grass. So,
yeah,
that's scary.
Let me say about Greenland. I was there in 2007 with a group, and it is melting quickly. And when you talk to locals in Greenland, in the 5 generations that the people I met with go back in Greenland, they've never seen anything like it. And that was 5-6 years ago, and it's melting faster today. I think the figure you saw was that this last summer, 2012, that 97% of the huge Greenland ice sheet was in melt mode and being reduced. And that has never happened before in thousands of years because the higher elevation stayed frozen even when there was some melting around the edges. But I think it was that 97% factor you saw. But that's just related to if you looked at Greenland from space or from a satellite or a map even, of what percentage of the ice sheet was melting. So all but 3%. It's still, again, about 10,000 feet thick, round figures, 2 miles. And in places it's melting 100 feet a year. And that's just an approximation because it varies. But what's of greater concern is that the big ice sheet, which covers the island, is kind of flat, drains to the ocean by means of glaciers, these meandering rivers of ice that we've all seen pictures of. And those glaciers are rapidly increasing their speed, and as they get to the ocean, they calve off in icebergs. And that's what will raise sea level over the next decades and centuries. And they've doubled in their speed in the last, let me think, certainly in the last decade, they've about doubled, and I think it's actually more than that now. But it's a huge increase in their speed, which is what's carrying the ice to the ocean. And as you drop those big ice cubes called icebergs into the ocean, they slowly but surely do raise sea level. Now, it's interesting to note that while those glaciers do raise sea level, when people see photos of the shrinking polar ice cap around the North Pole, they don't raise sea level because it's floating sea ice. It's like ice cubes in a glass. So it's all part of this. We need to get our facts straight because a lot of people assume the melting ice around the North Pole raises sea level, which it doesn't. Glaciers, which are disappearing very quickly, the 72,000 glaciers in the world that are tracked annually, 90% of them are melting. A lot of them will disappear, like Glacier National Park will be without glaciers in 10 or 20 years. But if all the glaciers melt, we only add a foot or two to sea level rise. The real problem is in Greenland and Antarctica.
I see. Now, there's a lot of debate that goes on, especially with these radio shows and other, so-called experts, I guess, who some will say that it's man-made global warming, and then there's others who say the sun is heating up, and that's what's happening. So I'll ask you, do you know of any, other planets in our solar system that might be going through the same thing that we're going through right now? Is there any way to know that?
To my knowledge, no, there's no planets in our solar system going through this. There's variations between us and Mars and Venus that relate to the percentage of carbon dioxide in the atmosphere. Carbon dioxide is an incredibly powerful insulator. If we didn't have the one molecule in 2500 in our atmosphere, Earth would be about 60 degrees colder than it is now. So carbon dioxide is just an incredible insulator, which is why we're changing the atmosphere and the heat of the Earth as we add carbon dioxide to the atmosphere. But to your question, is it caused by man or is it caused by some natural thing? Again, we can actually balance the carbon dioxide equation pretty well now in the heat balance. We know that the Earth gets 342 watts per square meter over the entire surface of the Earth. We know, we're clarifying how much is contributed by carbon dioxide and how much is reflected by sulfur dioxide and how much is added by black carbon, the soot that comes out of diesel cars and simple stoves that burn coal or cow dung. We're zeroing in on all of those numbers. And even most of the skeptics, like a very eminent scientist named Richard Mueller from Berkeley, was funded by the Koch brothers, who have really disputed a lot of the global warming evidence. And he ran a project which, over the last 4 years, analyzed millions of temperatures. And he said in front, when he started, that it was to try and prove the inaccuracy of the temperature increase that was being reported. And he publicly then wrote an op-ed in the New York Times which said, no, the world really is warming. I'm just not sure if it's human-caused. And then a year later, this past summer, in July, I think it was 28th, he wrote another op-ed which said, Confessions of a Converted Climate Skeptic. He and his daughter and a group of eminent scientists, having gone through millions of temperature records and looked at the numbers with incredible detail, said, you know what? We're 90% of the cause. And that was largely funded by the infamous Koch brothers, who either don't believe this stuff or certainly dispute it. So more and more the skeptics are coming around. In fact, I think if you step back and said, what were the arguments of skeptics a decade ago, it would be is the Earth's not warming. And then it changed to, okay, it's warming, but we're not causing it. And now it's, we're warming and, okay, maybe we're causing it, but there's nothing we can do about it. It seems to be a changing story and a winnowing band. The number of PhD scientists who are disputing it is getting pretty scarce. It's almost like, the rent an expert crowd. There's about a dozen of them, and they seem to get marched down to all the same meetings. disputing that man's causing this, but often it's proven that they're funded by the coal industry or, some other special interest. A few of them probably believe it.
Yeah, see, I would have no problem believing at all that humans are contributing in a big way with a lot of the nasty things that we do on this planet, without a doubt. But no matter what people believe is causing it, the fact is it's happening. We're seeing it every day. And I think that the reason a lot of people have a hard time believing that man contributes to the temperature rise and the climate change is because of the scandal that came out not long ago about the scientists who were caught tampering with the data. I think that's something that sits on people's backs just a little bit when we talk about man-made global warming.
You're right, and it was very unfortunate the way those emails were worded, and I think it's caused the scientific community to be far more careful, realizing that a quip, a remark that could be misinterpreted, because the independent panels and some judicial reviews and academic reviews that went through those in painstaking detail, almost like a court hearing, concluded that there really was not what it appeared to be. But regardless, it was careless. But I liken it, even if it was at the worst case, even if there are a dozen good scientists who were suppressing some numbers that didn't make their case. Let's just say if that were the case, and that was largely proved not to be the situation. But even if it was, it'd be like a bad doctor or a bad policeman, okay, or a crooked banker. You don't discredit a million scientists around the world and graduate students in all countries who are trying to make a name for themselves and who care about their kids and their grandkids, because maybe four guys exchanging emails said, you know what, let's not talk about this number because it doesn't make our case. Okay? If that's the best evidence that the data is manipulated, that's not a really good argument.
And I would agree with you on that. That's like saying, you have one nationality that might do a terrorist act, so you say that they all are guilty of it. So same kind of scenario. So, yeah, I'm with you on that. Now, you went on some exhibitions. Tell me about those. Got a question from the chat, too, that I'll get to you in just a minute here. But I want to hear about your exhibitions. What did you find? What was it like?
Well, again, I started studying old sea levels having no idea where this journey would take me when I was in college 40 years ago. And I was just fascinated that they went up and down 300 or 400 feet. I was in the diving business professionally, but lived in the Bahamas and where the water's very clear and did thousands of dives there, but all over the world. But when I was in the very clear water in the Bahamas, and because of my geology background, I would look for these ancient shorelines and beaches 100, 200, 300 feet underwater. And I just kind of I said, oh, yeah, that's back in 20,000 years ago when sea level was down this far, et cetera, or in caves. You could see evidence of it. So those might be considered expeditions. But when I started really looking at this in some detail was probably 15 years ago, 1997. I had some late-night meetings with Jacques Cousteau before he died, and we were talking about how things had changed in his 70 years, looking at the oceans and the planet and perspectives and how to communicate, and that certainly got me looking more carefully. And then I really honed this investigation, if you will, and went to Greenland and Antarctica. But I will take it back to an intermediate expedition, which in hindsight was I should have recognized for what it was. In 1985, I did my first expedition to the high Arctic, maybe about 800 miles from the North Pole, diving into the polar ice cap. And we were out on the sea ice with some very experienced Inuit or Eskimo guides. And again, these people could read the ice like you and I could read the street in front of our house. And they know exactly what's happening, even though it all looks white to us. They can tell nuances that we would never see. And we were out there for a week of diving on this open sea ice, and there were leads or cracks in the ice. And one of our 6 snowmobiles went through the ice. It was too thin. And it was a disaster because we were hundreds of miles from a village. And we had to kind of double up on our sleds and our gear and our dive gear and cameras and all that. And I remember at the time the Eskimos and our lead guide, who was really revered, a guy named Amishi, they were apologizing that they had let this happen, and they were saying that this was unusual that the ice was this thin. And there's actually a word they use called unianatuk, which is an Inuit word meaning weather behaving unusually. Mm-hmm. And I didn't recall it at the time, but I researched it afterwards when I read it in a book by Heidi Cullen called Future Weather. And what I realize now is 25 years ago, there were the early signs of warming and thinning ice. And when you piece it together, there are many cases like that in the Arctic where the polar ice cap around the North Pole has been frozen for 3 million years. When I studied it, there was never any hint that it would thaw this century or actually in the next 500 years. And now it'll be ice-free in September, which is the warmest month of the year, perhaps in 2016, but certainly the estimate is by 2032. The fact that the North Pole will be ice-free, even if it's just for a month, in our lifetimes, is such a stunning event, considering that the Arctic's been frozen for 3 million years. It does put in perspective that we are in a different era.
Oh, we certainly are. We certainly are. Now, I have a question from the chat I'm going to throw at you here. She says, it says that you have explored under the polar caps, which you have. It says, I have read some information that there are openings at the polar caps where one can enter inner Earth. Said something about that there's a blue sun. And let's see, I'm trying to make it out here. And it said that there were civilizations that inhabited. Have you come across any information about this in your explorations?
Interesting question. Okay. Part of what you said, I have no idea, the blue sun, et cetera. And let me clarify two things, partly to agree with something she's querying. First of all, we should separate that, again, the North Pole is frozen sea ice, which is quickly melting. And that's just an ocean up there that's been frozen for 3 million years, but will change. When I say the polar ice cap, I mean the North Pole. Antarctica is a frozen continent, like Greenland, but 7 times bigger, or 7 times more ice. Antarctica and Greenland are islands, solid ground mostly, that are covered by 2 miles of ice. So we need to distinguish that there's a real difference between going under the polar ice cap. You can't really go under Antarctica. Under a few overhangs, and there are a few exceptions to that. But generally speaking, you can't go under Antarctica any more than you can go under the United States. So just to clarify that. As far as have I found any evidence of these other civilizations, or can you go into the Earth, I don't know what going into the Earth refers to. I mean, you can dive down deep in caverns anywhere in the world, but you're not diving into the Earth. You're not going below hundreds of feet. So I don't know what that refers to. I don't know if it's real or some fiction. I don't know. But I do know, as a great example, that when you realize sea level was down 390 feet, almost 400 feet, 20,000 years ago, there's 2 or 3 great insights about that. One is the fact that it's been up at this current level for 6,000 years is why we tend to believe it's not going to change, because that's all of recorded human history. Our written record goes back, the New Testament, the Old Testament, 5,000 years. When you get back into Egyptian writings and Turkish and Chinese, you get back to a written record that goes back 6,000 or 8,000 years. Round it up to 10,000. That's human civilization in the broadest sense. But for most of that 6,000 or 8,000 year mark, sea level's been pretty much where it is. But it did rise 65 feet in 4 centuries, around 14,000 years ago. That's a foot a decade. Can you imagine that? A decade after decade for 4 centuries of the ocean rising more than a foot per decade is mind-blowing. And it probably accounts for the ancient stories of the biblical flood, which is also in the Quran, and also the myth of Gilgamesh, and lots of different stories that are in our collective cultures that talk about the ocean rising in really historic times ties in with this rising sea level. So that's kind of interesting. And the third point, which again may have a little bit of insight, so I've been studying this for 3 or 4 years and putting together this timeline and looking at the thousands of years and the magnitudes of sea level change. And I was on a different project up in British Columbia last year, just about a year ago, and on some islands called Haida Gwaii, which used to be known as the Queen Charlotte Islands. They're on the border between Alaska and northern Canada, an island off the coast. The Haida Indians have been there for at least 13,000 years, continuously. And while some people would say it's a primitive civilization, they're very much in touch with the forests and the seas. And again, they have this really rich oral tradition. They actually train their youngsters to not only repeat oral histories, but they grade them on accuracy, and the storytellers are the ones who get it most accurate. So their oral history probably has a lot of validity. And when I went up there, I found that when I told them about my studies about sea level rise, just in passing, they asked, what else am I working on? And I told them I'm working about sea level rise. They said, oh, the flood. And I said, what do you mean the flood? Because I hadn't heard that anywhere else in the world. He said, oh, well, it's one of our main oral myths, or not myths, our oral stories, our oral traditions, I should say, stories that tell us about our world, about the raven and the ocean and the flood and so on. And I said, tell me about it. And I actually put it in my book because it's a fascinating story. It goes back to 13,000 years ago when they inhabited these islands. And when you realize that that's when sea level rose 65 feet in 400 years, it's an amazing validation of what we know geologically. So there's an example of where we have a story of a different peoples or a tribe, a native tribe, that really does remember sea level rising.
Yeah, it's a long time. 13,000 years. They've seen a lot, especially they kept records of it. That's fascinating. John, hang on with us for a moment. We've got to take a break here. Exactly how has man changed climate? How has man changed the climate?
Sure. The greenhouse gases, there are about 30 different greenhouse gases, including water vapor, but the one that we affect is carbon dioxide most predominantly, certainly in the modern era, because we liberate it from the ground as we burn fossil fuels. And we can verify carbon dioxide levels going back about 800,000 years because the ice sheets of Greenland and Antarctica now have ice going back 800,000 years piled up. And by drilling ice cores, we can sample those just like drilling a core through a tree trunk and get tree rings and knowing about past climates of the last couple of hundred years. So when we look at these ice cores, which have layers of ice which have been compacted and can be dated, we can go back and sample carbon dioxide levels. And what we know is that going back as far as 800,000 years, that the range of carbon dioxide levels from these little tiny bubbles in the ice that we can actually sample and measure percentages ranges from 180 parts per million to 280 parts per million. And that goes up and down to the ice age, which makes sense because the amount of vegetation on Earth changes, and vegetation changes carbon dioxide into oxygen, as we know, plants do. So that all makes sense. And then if we want to consider the last million years up until the last couple of thousand years as the natural cycle or the natural state, even though man has been around for a long time, the natural levels of carbon dioxide range from 180 to 280. Today they're 393 parts per million, and they go up 2 or 3 parts per year. On the current path, we'll be at somewhere between 700 and 900 parts per million by the end of the century. Well, that's getting just a catastrophic level of CO2. CO2 is a benign gas in microscopic quantities and is quite natural, but as we know, if we zipped ourselves into a plastic bag, we would fairly soon convert the oxygen into carbon dioxide and we would die. Carbon dioxide at a certain level kills people. It's benign to a point, as are most substances, including cyanide, botulism, and everything else. there are lethal thresholds. And the way we've changed climate is that we have liberated millions of years of carbon in the form of petroleum and its other products, coal and all those other fossil fuels, which took millions and millions of years to form and put under the earth as part of a natural cycle. And in the span of a century, we've burnt and liberated most of that. We can see the smoke going up. We can measure the parts per million. The equations add up. We have brought the high level from, again, 180 to 200, 280 is the range, so the high level is about 280 parts per million. It's now at 393. It is 40% higher than at any time in the last 10 million years. And that's how we've altered the greenhouse gas, and that's trapped more heat. It's a lot like if we put more insulation in our attic but didn't turn the furnace down, the house would get hotter. That's what we've done. We've added insulation to the atmosphere in the form of carbon dioxide, and that has had a lot of knock-on effects of things that it has triggered. But that's the fundamental issue. And then, of course, there's the fact that we have 7 billion people headed to 9.5 billion. And that's certainly something that we've done to affect the planet. I don't think there's, any going back on that. And the truth is, I don't think there's any quick going back on sea level rise. I think we need to adapt to a new world. I don't say we should go back to a primitive state. I advocate we need to adapt to rising sea level in a shoreline that's going to move inland. I think we need to put some price incentives in place so that we're all motivated to get off of carbon over the next 30 or 40 years. And I just think we need to look at the shoreline differently than the past 6,000 years.
Okay, and even if it's my understanding, even if we didn't start another car, didn't burn another drop of fuel, and stopped everything that's damaging, that it would take, 1,000 years before it would even start to reverse?
Well, it'd take 1,000 years before the ice sheets would start rebuilding and growing for decades or longer and slowly reducing sea level. That's what would take 1,000 years. In a matter of decades, we could slow the warming, and we should try and do that. But that's the reality of timescale. We can't stop it immediately. So we should try and slow it as a planned policy of realizing that we're really hurting our kids, grandkids, and generations beyond, and it'll be our legacy if we ruin the environment, meaning the climate in this case. But we should adapt to what is happening. And again, it's happened before, but now we've really changed the cycles significantly. And it's an attitude. I mean, we can deal with cancer and AIDS and terrorism and putting a man on the moon. We can do amazing things when we set our mind to it. But if we pretend it's not happening or deny it's happening or say it's not politically convenient or, gee, it'll hurt a few jobs. But when we realize that melting the ice sheets for the first time in 6,000 years is going to cause us to move every coastal city over the next century or two, we have no idea of the economic cost that we're setting in motion. And it's like Social Security and the federal debt and everything else. If we just want to kick the can down the road and say, la, 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 don't bother me, sure, we can do that. But I do believe that most people care about their grandkids and beyond. And that's the message
Yeah, absolutely. I agree with you. And, this doesn't just affect the coastal areas. This changes weather, in the inlands as well. I've seen some crazy stuff lately, last few years. Tornadoes where you never expect to see tornadoes, all kinds of flooding. I mean, it just keeps getting better every year, it seems.
Yeah, weather's getting weird, as somebody says. I think it was Tom Friedman. We're getting weather weirding. What we're getting is climate destabilization is probably the best term I've heard. The Earth is warming, but as the Earth warms, the currents of air and ocean change that give us our typical annual patterns when we expect certain things to happen in April or certain things to happen in November, or the hurricane season to go from a certain date to a certain date. All of that's coming unglued because we're warming the planet. And as the planet warms, currents change, El Niños, La Niñas, etc. And as those things change, the cycles that we've grown up with and known throughout human history are going to change. Some places will have more drought, some places will have more floods, some places will have more snow. It's just going to be a very different series of weather patterns. I think, Michael, that I skipped over a question. I realized you asked me about solar cycles before, and I somehow went off on a tangent. Excuse me. I should come back.
Quite all right.
Let me just quickly cover solar heat input because it's very relevant here. I mean, the amount of energy we get from the sun largely determines our weather. It's that, the spin of the Earth, and the placement of the continents and the oceans and the interaction of currents that determines weather. Highly complex, millions of interactions a day, or billions. But the driving force is heat from the sun. People are absolutely correct. And we know how much heat we get from the sun, 342 watts over every square meter of the Earth, average globally on an annual basis, easily measured by satellites. There are different solar cycles. There's an 11-year solar cycle. There's a 21,000-year solar cycle. There's a 26,000-year solar cycle and a 40-some thousand, 41,000. And those line up with different periods. Anybody that, has laid out different graphs to know how they intersect or have harmonies at different points will appreciate that when you have that many different periods, wildly different, sometimes they'll all line up and then the effects reinforce. Other times they kind of go in opposite directions and they actually cancel each other out. But so the solar heat's really important. What triggers an ice age every 95 to 125,000 years is a variation in solar heat, and it has to do with how the planets line up. We now know that. It's called the Milankovitch cycle, and it's a difference of about just under 1%. Actually, it's substantially under 1%, but less than 1% variation in the amount of heat the Earth receives from the sun on a 100,000-year roughly cycle puts us into an ice age or takes us out of it. It's a triggering event. When people talk about solar variation, though, they're usually referring to the 11-year solar cycle because that's within our human time reference. And every good study, latest one I read was by the U.S. Navy, who's very concerned about rising sea level, totally debunks the idea that the changing climate is because of the solar cycles, because the relevant short-term cycle is 11 years, and the climate warming and the melting ice has not followed that 11-year cycle.
I see. And, somebody had made a really good point the other day to me and said, well, if the sun was heating up other planets in the solar system, if it was causing those global warming as well, then, they're further away, so we would be fried if that was the case. And I thought that was a good point that he had brought up.
Yeah, again, this over long periods of time, over billions of years, the sun will expand, and billions of years from now, we all learned this in school, billions of years from now, we're going to be incinerated. But that's a different time scale. That's not our concern here. We're talking about, for the foreseeable decades, centuries, and just seeing 1,000 years out to see where it's going, but we're concerned about a century or two. Unless we think that we're doing something that is going to really come to a head 500 years from now and kill everybody, that would be a moral issue. It may not be a media concern, but I don't think any one of us wants to enjoy life but not have regard for the future of humanity. But that's not really what we're talking about here. We're talking about what's going to happen this century, and Hurricane Sandy brought it home to a lot of people because, again, few people considered the possibility of New York being devastated by a hurricane. And, of course, we now can see, $60 billion of damage, I think, and there's some people out in the Rockaways that still don't have electricity back 3 months later.
Yeah. Yeah. Yeah, and Riscola asks in the chat room, he says, and I think you covered this in the beginning, but he says, where does all the water come from when the ocean is rising? He asks if it's all the ice melting.
Yeah, it's probably, well, it will be the ice melting. Here's where it gets a little tricky. In the last century, the ocean has risen, global average, about 7 or 8 inches. The ocean has warmed about 1.5 degrees Fahrenheit, 0.8 degrees Celsius. As most objects warm, we know that we're out in cold weather. When parts get warm or cold, they don't fit right because things expand differently. But most things, when they warm, they expand. Well, as the ocean has warmed for the last century, we've had about 3 or 4 inches of increased ocean height because of what's called thermal expansion, just from the warming. But that effect will get less in the coming century proportionally as the ice sheets in Greenland and elsewhere melt. Now, where the second level it gets confusing, besides the thermal expansion, which nobody thinks about, is, again, that the polar ice cap around the North Pole is floating sea ice, so that doesn't do anything. It's only the ice on land, and what we think about first is the glaciers. We may think about Greenland and Antarctic, which are 2 big, flat, 2-mile-thick ice sheets, but we tend to think of the glaciers, whether it be in, Glacier National Park or the Alps or Peru or Alaska. The glaciers are very visible. They are on land. As they melt, they do raise sea level, but in proportion, they're not significant because the amount of ice that's in all the glaciers in the world, and there are 72,000 glaciers that are tracked and monitored. That's not all the glaciers. There's well over 100,000 glaciers in the world. But the 72,000 tracked and monitored glaciers, when all the glaciers melt, in fact, sea level will rise a foot or 2. So when you look ahead this century, okay, maybe that'll contribute a foot or 2, but the big problem is how badly the Greenland and Antarctic melt, because that's where 99%, literally 99% of the world's fresh water is stored. And it's those 2 ice sheets melting that will dwarf the glacier effect and dwarf the thermal expansion effect and the other couple of minor effects. That's why looking ahead to the danger of them being in melt mode now, Greenland and Western Antarctica and the Antarctic ice shelves and the Antarctic Peninsula, and East Antarctic isn't melting yet, but Antarctica overall now is in melt mode. That's why they're significant and why this will continue decade after decade after decade for at least 1,000 years.
I see. He also asked if you knew anything about the Greenland UFO, and that was an object that was supposed to be below the ice that I guess scientists were trying to explore and research. I don't know if you know anything about that.
I don't know anything about it. I remember seeing some reference actually to some kind of a supposedly foreign celestial object in Antarctica, I think. And I've seen a couple of spurious, or I don't say spurious, but references to it. I have not investigated it. I have no knowledge of it. I can't intelligently or honestly comment.
Okay. All right. Now, do you think that possibly there's projects going on right now like that could be contributing to climate change, like cloud seeding and that type of thing? Or do you think that maybe they're doing it to try to reduce the effect of global warming and that kind of thing? Do you know anything about that, the cloud seeding?
Yeah, that's a good question and a hard one to answer in this way. First of all, when we say they, we all do it. What they're doing, okay. It's whether they, the bankers, or they the government, or they, the scientists. The truth is that's the first leading statement, because they is not a monolith, right? It's hundreds of thousands of people around the world, different governments, state, federal, et cetera, different countries doing different things, and they're not all acting together for sure. Right. No matter what the conspiracies are, that there's lots of different things happening. So it's hard to say what they're doing. But having said that, certainly there are experiments with cloud seeding to see if we can affect hurricane paths and tornadoes. Certainly there are experiments trying to figure out, could we geoengineer, could we alter the planet's climate to compensate for what we've already unleashed? There are experiments with that. Some people think that's really too dangerous. Some people say, well, it may be dangerous, but it may become necessary, so we should at least do some early experiments. Those things, I believe, are happening. I don't have firsthand knowledge of any of that, but it's perfectly believable those things are happening. I've also seen other stories about the contrails and alleged allegations about, mysterious government programs that seem to have a sinister tone. I'm not familiar enough to comment yes or no.
Okay, so now what happens if we continue to ignore the fact that climate change exists, no matter what anyone thinks is causing it or happening? But what is the outcome, and how soon should we see drastic effects? I think we already are. I mean, with Sandy and all, but
no, you've answered your own question.
Outcome?
But thank you. You've answered the question. It's absolutely true. 20 or 30 years ago, it was predicted by guys like Dr. James Hansen and Dr. Hal Wamlis in Miami and others that we were going to see the effect. In fact, it goes 1978, as I cite in the book. Dr. John Mercer talked about Antarctica melting and predicted it, almost nailed it. So these things have been described. In fact, the calculations of what happens with greenhouse gases, with carbon dioxide, the calculations were done in 1896 by a Swedish guy named Svante Arrhenius, and he did it with pencil and paper. It took him a year to do the calculations, and they're not that far off from the modern calculations with satellites and supercomputers. Pretty amazing. But that points to how fundamental the physics are. So, again, this isn't some brand new hypothesis and problem. We've seen this coming, to your point. It's getting worse. Sandy's kind of put, a big punctuation mark on it, as you suggest. But you asked me, what's going to happen if we don't do anything different, if we continue business as usual? Well, there's two things that are going to happen. One is that this rate of sea level rising, which for us means the shoreline moving inland, is going to continue to accelerate decade after decade as the ice sheets melt. And we're going to be forced away from the shoreline, as started to happen in New Jersey 3 months ago. People are having questions about rebuilding. And in Miami and places in Virginia, they're having to raise houses and raise roads because somehow, for some reason, they're underwater a couple of days a month. That didn't happen 30 years ago. So we're starting to see the signs of rising sea level moving the shoreline inland. And that's exacerbated or worsened dramatically with storm surge, and then when it happens at extreme high tide, as happened with Sandy, through bad luck. So we're seeing those signs, and that will just continue and it will accelerate. That we can predict. It's as sure as melting a block of ice, putting it out in the sun. There's no doubt about that. What we can't predict with certainty is where we will get these changed weather patterns of droughts like in Texas or floods like in Bangladesh and up in North Dakota last year and along the Mississippi River in the Philippines and around the world. So where there are going to be droughts, where there are going to be floods, where there are going to be more snow. We can't really predict that because that's a function of two things. As the oceans warm, we get more evaporation and more moisture in the air. That's measurable. That moisture's got to come down. It's going to come down as rain or snow, depending upon the temperature. But the patterns of temperature in the ocean and atmospheric currents, like the jet stream, are moving their location as the Earth warms. And the truth is, even the best climate models can't tell us for sure how that's going to play out over the next 10 or 20 years. It's far too complicated. We keep doing the best we can. The models get better and better, but that's an evolving science. But the sea level rises and the shoreline moving inland, that's a slam dunk.
I see. Now, let's say a couple decades, and this keeps worsening. What is the likelihood, I guess how far can you expect oceans to rise and, coastal areas to start being submerged? I guess basically is what I'm getting at is, should people start selling their real estate on the coast, or do they have a little longer to enjoy it?
Well, again, I get the question probably every day, so I have to smile, but it's a very fair question. To give an honest answer, you have to think of it this way. There's 5 components that are going to put property underwater. One is the current melting of the ice, which we described, and that's slow rise that, let's say, is going to be 3 feet by the end of the century, and it's not even a straight line. The worst part of that's going to happen toward the end of the century. So it's estimated between 3 and 6 feet, to be fair. That's kind of the range of estimates. But that's just with the current rate of melting, not assuming any positive feedback or tipping points, as we call them. What could be tipping points is the 2 good examples is the release of methane, which is happening now in the tundra and from the seabed and in lakes in Siberia. As the world warms, methane gas is escaping, and we can ignite it in some places. We can certainly collect it and measure it. It's hard to predict how quickly the methane will release. That's the unknown that could greatly accelerate the warming and the melting and the rising of sea level. That's a variable that we just can't pin down. And it's huge. Methane is hundreds of times more powerful a greenhouse gas than carbon dioxide. It eventually deteriorates into carbon dioxide, and when you average it over a century, it's even then with the averaging from the powerful methane hundreds of times to carbon dioxide, let's call it a value of 1, it averages out to 26 times more powerful over a century than carbon dioxide. So methane's a big problem, and we just really can't predict how quickly it's going to come out of the permafrost and seabed. That's the unknown. The third factor which is going to contribute to sea level rise is tides. They go up and down, and then we have seasonal high tides at least once a month and quarterly on the lunar cycle, the extreme tides, the lunar tides, if you want to call them. So like Sandy, hit at a lunar high tide, which made it that much worse. So now we have long-term sea level rise. We have an accelerating factor like methane release or the glaciers in Antarctica. We have tides and extreme seasonal tides. That's the third factor. And then on top of that, we have storm surge. And Sandy was the perfect textbook case, as I wrote about a week before it happened, or wrote about a year before, but published a week before it happened. Sandy showed what can happen when all those first 3 things line up with storm surge, as Sandy brought to New York. And then, as you alluded to, it was an unusual pattern. It went from southeast to northwest, which is what I described, hitting Atlantic City, and the right flank was the worst part of it, which hit New York Harbor. As again, somehow I had this premonition, but not really. I was really just describing a scenario. But when that storm surge adds to it, you got a 9.5-foot wall of water on top of all the other factors of seasonal high tide, sea level a foot higher than a century ago, and those factors. And then the fifth factor is that certain places have a geologic or topographic extreme vulnerability. Examples are New York Harbor. The long arm of Long Island creates a broad funnel with New Jersey, if you will. And with a storm coming from the southeast, as this one did, it funnels the water and amplifies it. And it's further amplified there by a hidden feature. The shallow, long underwater shelf piles the water up when it comes from the southeast toward the northwest. And that's exactly what happened. So we had 5 factors there, well, 4 factors actually. We didn't have the methane release and the Antarctic situation. We had long-term sea level rise, we had storm surge, we had extreme tide, and we had a geologic vulnerability, which made Sandy far worse than anybody expected. Another example of a vulnerability, just to be quickly here, is South Florida and many coral islands are porous limestone. You can't even build a seawall around them because the water just percolates up through the ground in the middle of the island or far inland. So that's a problem that New York doesn't have. New York is granite and could be protected by a seawall. But another example of vulnerability would be like Providence, Rhode Island, or Sacramento. People never think of them, but Providence is at the top of a triangular-shaped Narragansett Bay, and when you get, it's at even an inch of sea level rise in the ocean, you can get a foot of sea level rise in Providence. And Sacramento River is another example. So it's all over the world that we just don't foresee these things because they aren't happening yet, but as you say, they're starting to happen. We're starting to raise roads. They had to raise 6 houses in Larchmont, Virginia, outside of Norfolk, at a cost of, I can't remember what, I think it was about $1 million, because 6 houses were getting flooded each month.
Wow.
That didn't happen 30 years, 20 years ago.
No.
Virginia is an example, actually, of something else. And I should have mentioned this when we were talking about the factors. The land does move up and down. It's called uplift or subsidence. And Virginia, like New Orleans, is subsiding. The land is going downward. So the relative or effect of sea level rise is doubled pretty much there. Conversely, in Alaska, Alaska's rising or uplifting, so sea level is going down in Alaska, which points out that you have to look at sea level rise, surprisingly, even though water does kind of equalize itself around the globe, but there are anomalies to that or variations. And then there are places where the land is going up or down. So it's a lot more complex, and that's why it takes me 190 pages to explain it, although there's a lot of diagrams, as I think you know. But you'd think that the ice melts, sea level rise, and it's the same all over the world. It's not.
I see. So Alaska might be a good place to move to maybe in 30, 40, 50, 100 years.
Sure.
Yeah, so, you know, and I live here in Columbia, South Carolina, and when I first moved here in 2008, what amazed me is the whole place is sand. I mean, it's just all sand. And I got to thinking, and I said, I bet that at one point South Carolina was at the bottom of the ocean. That's probably reigns true then. So, I mean, this has happened before.
Yeah, you know, it's interesting. You're fairly far inland there in Columbia. Of course, if you drove out to the coast in Charleston, it'd be the low country. It'd be a different story where they have a much greater problem with sea level rise and storm surge. But back to your point about marine fossils and finding them and what's underwater, that's confusing for two reasons. That because we find marine fossils, there's shark's teeth in Kansas, now 1,200 feet above sea level. There's actually marine sediments at the top of Mount Everest, the highest point on Earth. But that doesn't mean the ocean was ever that high in either location. This uplift has to always be considered and kind of worked back out of the equation. The reason that there's shark's teeth in Kansas and marine sediments on the top of Mount Everest is because those pieces of land used to be near sea level or maybe 100 feet above, but they rose through a process of mountain building and uplift, which comes from a variety of geologic forces that are, you know, far too complicated really to go into in detail here, I think. But any geologist, and if you want to check this out, I mean, obviously there's lots of information on the web, or go to any high school or college geology book or professor. It's a fascinating subject that landforms over a period of years and decades and certainly centuries or thousands of years, they move up and down little bits. And that may be enough to accelerate or accentuate sea level rise or to negate it. So those are just further examples of how you've really got to look at this with some sophistication. We would never say that sea level has been at the top of Mount Everest at 29,000 feet. Because again, when all the ice melts, it can only go up another 212 feet above the present. But of course, that would be a disaster. Yeah, absolutely. Now, before we take our next break, another question here for you. How much of an impact do you think things like Fukushima, that disaster, is contributing to the process of climate change? And obviously, you know, that just happened a couple of years ago. So, but how much could things like that speed it up? I'm glad somebody asked that. Fukushima was the result of a tsunami, right? Which is a tidal wave, but sometimes called a tidal wave. But we know what these big tsunamis are. We've seen enough of them in the last decade. Tsunamis are not weather or climate events. They're seismic events. They're caused by movement of plates of the Earth, effectively earthquakes under the ocean. So the cause of Fukushima was an earthquake. Nothing to do with changing climate, although there's a theory about it, it's a very obscure theory so far, not worth paying a lot of attention to. But what Fukushima did creating, what was it, I think, I don't know, 50 or 60-foot wall of water, I can't remember, that wave that went up there and destroyed the nuclear power plants has had a huge repercussion because Japan doesn't have natural energy sources and made a big part of their energy from nuclear, and having shut down essentially all of their nuclear power plants is now burning fossil fuel. So ironically, while the tsunami and wave and wiping those villages clean, the devastation didn't directly change climate, the fact that it caused Japan and many other countries to change their policy about nuclear energy is going to have a big effect. It makes the cliff much harder to scale, because we've got to create the same energy without carbon we did before, and nuclear energy, which creates power without producing carbon emissions, is now off the table for Japan. So, on the other hand, on my theory that when humans are challenged, they do their best work, the Japanese are very resourceful people. And I think what this has done to their economy, and knowing their inventiveness and their tremendous discipline, as we all know from the quality of their cars and electronics and everything else, some of which may be copied from us, but certainly they do things we can't, that they're a very industrious people, and they can really focus on a problem. And I'm excited to think that Fukushima could have maybe a silver lining, that it's going to really cause Japanese engineers and industry to do everything they can to work on energy efficiency and zero carbon fuels or low carbon energy. And I wouldn't be surprised if in the next 5 or 10 years they don't come up with some really clever ideas.
Oh, I hope you're right. I really do. I hope you're right. And, what I worry about is with all these nuclear power plants we have around the globe, something like maybe an EMP or something from the sun, or even man-made, that maybe shuts the power down for a lengthy period of time, and we've got a lot of these things steaming off on the planet. That would definitely be catastrophic. So I hope they do come up with different means of power and energy and get rid of these things, because I see them as death traps.
Mm-hmm. Yep.
All right, John, let's take to it here with my guest, John Englander. And, again, we've got him linked up over on latenightinthemidlands.com, so you can go over and check out his website, his book. Great book. I suggest you take a look at it. It's got a lot of fact in it. And, John, am I to understand that the Vatican has actually put out a paper on sea level rise and climate change? They seem to get involved in a lot, don't they?
Yeah, it's really an amazing story, and as I put the book together, it only dawned on me what bookends it is. That I talk about how Galileo and Copernicus and the whole Earth being not being the center of the solar system, that was so controversial 400 years ago, and the Church did the Inquisition and house arrest for the rest of Galileo's life. Is now juxtaposed against a totally different situation where the Vatican commissioned through the Pontifical Academy of Sciences a study about climate change, and their paper in January 2011, I believe it is, was brilliant. It's only 17 pages long. It's plain English, and they assembled an eminent panel of scientists working with their experts. And their 3 points are really clear. They say that we need to wean ourselves off of fossil fuels quickly, that the impact on climate change, including sea level rise, and they're very specific about that, and it's very 3 short paragraphs, will have devastating consequences, and that we are tampering with Mother Nature, and we need to be aware of what we are doing and alter our ways as quickly as possible. And their final conclusion is that the cost of dealing with this now and prevention will be far less than the cost of dealing with the effects if we don't solve the problem, which is brilliant. I mean, and I kind of close the book with that in chapter 17.
I see. Now, isn't it amazing how we put so much, and when I say we, I mean as a humanity, we put so much money and effort into destroying ourselves, like through wars and God knows what else, rather than put all those resources. I mean, can you imagine where we'd be right now if everybody just put their heads together to better mankind rather than destroy it? We're so self-destructive, aren't we?
We really are. It's kind of interesting. Of course, I think we all know that whether you look at it, from a religion standpoint or just morality or just human behavior, we all have tremendous good and we all have qualities which we're not so proud of, let's put it. And that's what humans are, I think. I mean, it's an interesting question. I won't get into the philosophy of it or the religion aspects, but we can do amazing things, but whether it be something as simple as Social Security and taking care of our kids, or Medicare and policies that bankrupt governments because we like benefits and we don't see the reason to be cautious, financially. I mean, that's a simple example, but it does deal with our air and water and pollution. And I like the free market. I'm going to tell you that I don't believe the state knows better, and I do believe that faced with rational choices, that most of us will do the right things most of the time. Now, there's a question to that, and but I think it's often when we tamper with the systems. I think that a lot of the lobbying money, the special interest, that's what distorts the systems. And I actually think government should get out of the way. I think that government should take care of people at some times in their lives. But my personal belief is that, like back to sea level, that coastal flood insurance shouldn't be a government function. We should have insurance companies competing for our business to keep the rates as competitive as possible, and not monopolies. We should encourage competition and have transparency, which the internet allows, but we shouldn't be subsidizing people with cheap insurance to build on the coast, which is what we're doing. The National Flood Insurance Program in the United States is upside down to about $20 billion. We're subsidizing it, basically, just like Social Security and Medicare and everything else. We shouldn't be telling people that, don't worry, FEMA will come in and rebuild. Now, I'm not saying FEMA shouldn't rebuild from Sandy, because we did rebuild from New Orleans, $280 billion. But I do know that as sea level rises, that to lead people to think that even if they build in dangerous, risky areas, that they can claim for the government to reimburse them has got to end, because there's no government that can afford to reimburse all of the assets and infrastructure and economic damage that will occur as sea level rises and the shoreline moves inland. It's just not possible. So it's like...
I was going to say, I think that, we should definitely take accountability. If we decide to live in a paradise-like setting, well, then you have to assume, everything that comes with it.
Yeah, that's right. I think if somebody's worth $100 million and wants to spend $10 million on a beach house on the coast where it's vulnerable, as long as they pay, either take the risk and know it and they're smart, or, aware, and don't expect us to reimburse them when it gets washed away, and they're willing to pay the insurance costs if it's available, that's their right as far as I'm concerned. But I think it's government subsidies, whether it be corn ethanol or coastal flood insurance or all the other subsidies the government puts out there, that distort the marketplace. That's my personal belief. I think intelligent free market decisions are generally good. We just keep clouding them with government policies and actions and reimbursements and subsidies.
I can't argue with you there. Government does need to get out of the way. That's for sure. Let me ask you this. So what would you say to those, because I've had this argument thrown at me before, people who say that more CO2 is emitted from, say, rotted trees and volcanoes and things like that than what man puts out. What do you say to those people?
Well, carbon dioxide has a natural cycle in the earth. I mean, it is emitted from living organisms, from rotting trees, in our world from cows that we raise that fart methane and so on. I mean, that not CO2, but greenhouse gases. I mean, there are lots of causes of it. And if you look at any one item and say, well, this is more than that, I mean, you're missing the big picture. The fact is that CO2 is produced by living organisms, that plants consume CO2 and make oxygen, and then in the long term, over 1 million years, that carbon dioxide is taken out of the atmosphere and through the weathering of rocks, where we get carbonates and stuff that in the sediments, and it's a very complicated carbon cycle that goes on over millions of years. But what we've done in the last century is we've liberated so much more from the burning of fossil fuels that's changed the equation, and that nature can't bury down deep quickly or combine into stable compounds quickly. So it's, when you have a dynamic, go back to the heating house. I mean, the house, like our planet, you can turn on the furnace, you can put insulation on the roof and seal the cracks around the windows, but if you want the house to stay at the same temperature, the variables have to stay the same. If you change one, something else has to change if you want the temperature in the house to be the same. If you put more insulation on the roof, you've got to turn down the furnace. Well, with carbon dioxide, it's the same thing. It's fine to say that carbon dioxide is produced by decaying trees. Fine. But that's been there, and that's part of the natural ecosystem. We can't get rid of that. But if we add to that by these greenhouse gases from burning fossil fuels, which were buried deep in the earth and would not have been liberated, and we've increased the amount of carbon dioxide in the atmosphere from 280, the highest it's been in 10 million years, and it's now at 393 and climbing, that's what's changing the equation. And it's a distraction or confusion to start talking about cow farts or decaying trees. We can balance the equations. We know the amount of fossil fuels we burn, and it does add up to this 40% increase of CO2 levels.
Okay. Do you feel that this has to do also with the mass animal deaths that we've been seeing, the birds falling from the sky and that kind of thing?
I think they're different phenomenon. I mean, the Earth's changing a lot. There's whether it be changes in magnetic fields, whether it be changes in concentrations of gases in the atmosphere, pollutants, whether it's microwaves. I mean, there's a lot of things going on, and I'm all for keeping an open mind and asking great new questions and trying to figure them out. But I'm slow to jump to say, that birds falling from the sky are tied in with climate change. I mean, there may be an entirely different cause, maybe a disease that's affecting their homing instincts or the direction-finding ability. We need to, investigate that.
Okay. Now, what can people do about this problem now? How can people better prepare themselves for these Sandy-type superstorms and climate change as it is and as it will be?
Great and really practical question as we start to wrap this up, which I appreciate in terms of you're asking that what can we do? Well, the common things people think of, like separating the trash and recycling and driving a Prius and changing light bulbs, those are or solar water heaters. I do most of those things, but they're not going to slow climate change. One is most of them, things like separating trash and recycling, don't save energy. In fact, some of them are more energy intensive. They save resources, which is good, but it doesn't get to the issue of climate change, which is caused by the greenhouse gas, which comes from burning, how we create power. So I separate a lot of sustainability from what will slow warming, which will slow the ice melting, which will slow the sea level rise. What do we do about it? The truth is, as we've talked about earlier, we've already warmed the planet enough, 1.5 degrees Fahrenheit in the last century, beyond what it's been for the last 10 million years roughly, that the ice is going to melt for 1,000 years, which has not happened for the last 6,000 years. And the shoreline's going to move inland. And that's a revelation. And not one person in 1,000 knows that. So if we want to act on that early information, we should. But it's not going to affect us tomorrow unless it's exacerbated by a storm like Sandy hitting at a full moon high tide, as happened with Sandy. And that can happen next week. It can't happen tomorrow because we don't see it coming, and we do know when storms are coming. But and it has to hit with a high tide cycle to really have the kind of devastating impact that Sandy did. But that could happen next year. So it's a risk factor. But I think that from a practical standpoint, I wouldn't worry about Sandy hitting again within a decade. It could happen. I can't tell you that. But I do think that if people are concerned about living on the beach, if they're elderly or they only want to live there 5 more years, it's perhaps worth taking the risk. But if they have coastal property that's close to sea level and the assets are important to them and they want to leave it to their kids or grandkids, they need to realize that probably over the next few decades the value is going to start diminishing as people are aware of the risk, or you have a Sandy-like event, and it could be anywhere in the world on the coast. So I think not panicking, but recognizing that after 6,000 years of being where it is, the shoreline is moving inland, that people can make an intelligent decision that if they're 60 years old and they want to plan their retirement when they're 85 and they don't want to move when they're 80, that maybe they need to think now about where would they like to move during the next decade. And I think that's a realistic question about location and movement and sea level. And then the second part is we need to support policies that get rid of the subsidized coastal flood insurance, that recognize the ice sheets are melting, and don't throw good money after bad and encourage bad behavior. And the third and final thing is that we need to tell our politicians that we believe climate's changing, that man contributes to it, and we need a long-term policy where we put prices on carbon, whether it be cap and trade or carbon taxes or whatever, to encourage a gradual shift from fossil fuels to fuels of low carbon or zero carbon. That's a good long-term policy. And Washington doesn't hear that because the energy industries don't want to change from the current situation. And we're seeing change. We're seeing solar and wind and so on, but there's still just a couple of percent. And the truth is we can't get off of coal tomorrow. But what I'm advocating is that we need to talk clearly and intelligently and tell politicians, listen, for the sake of our grandkids, and I word it just like that, for the sake of our grandkids and our legacy, let's start an intelligent energy policy that realizes that we have to get off of fossil fuels over a period of decades. That would be smart. And they need to hear that.
Absolutely, and I agree with you. I'm all for getting off the fossil fuels, and I think that it's the big energy companies, the oil companies and such that have made sure that we stay dependent on it. I mean, they get filthy rich off it. So that's something we definitely need to change. Where can everyone get your book, High Tide on Main Street? And if you want to throw out any websites or anything else that you haven't got to, by all means, go right ahead.
Thanks for the invitation. It's not often in bookstores yet. It's a boutique book still. It's only, I guess we've sold several thousand copies in a couple of months, but it's growing. But there's a website, hightideonmainstreet.com, just the booktitle.com, that will get them to a website with the reviews, and they can order it. They can also go to Amazon. They can order it online from Barnes & Noble. It's available for all the e-books. That's for the Nook, the Kindle, and the iPad. All of those have e-books of High Tide on Main Street. And there's also an audio book available from audible.com or from Amazon and iTunes as well. So audiobooks, e-books, and print can be ordered online. And the cost is $19.95 for the print and $9.99 for the e-book, so it's very reasonable. I did that intentionally. I want to get the word out. This isn't a book to make a lot of money. This is a book to change people's understanding and awareness and give them. There's 48 illustrations and images and very simple graphs in the book to make this easy to understand. There's no technical science in the book. I explain science just as I've been talking on this phone call or interview. It's as you know, and that's the idea, is to translate science and give people enough information that they're comfortable with the facts, the concepts, and the conclusions, so that it's not one opinion versus another.
Absolutely. Well, John, I want to thank you so much for taking time out to be with us tonight. And you're linked up over on latenightinthe-midlands.com. We're going to keep you linked up there, and I appreciate what you're doing.
Well, thank you, Michael. I've really enjoyed it. I've never had a 2-hour interview. I wasn't sure what that would be like, but it's been great to have the opportunity to answer questions and come back to them and deal with your listeners' questions that you've received electronically. So I want to thank you for taking the time and trying to tell the truth to your listeners. This is a word that needs to get out, and this is a revolutionary concept that the shoreline's moving inland for the first time in 6,000 years. It's going to take us decades to change people's awareness, just as it did about subjects like, the sun being the center of the solar system, or controversial things like evolution and stuff. These big concepts don't change quickly, and some of them are attached to emotion because of religious reasons or beliefs or political beliefs. And, I think we've got to blow away the confusion and the prejudices as much as possible, because this is the world we live in, whether we like it or not, and we should deal with the reality.
Absolutely. Well, John, thank you again, and look forward to talking to you in the near future. So thank you.
Okay.
John Englander is an oceanographer spanning many disciplines and areas of expertise. He is a global ocean explorer with personal experiences on expeditions under the polar ice cap, deep dives and research submarines, and visits to Greenland and Antarctica. His mission is to be a clear, objective voice on our changing climate and oceans. Mr. Englander's broad marine science background, coupled with dual majors in geology and economics, allows him to see the big picture on climate and look ahead to the large-scale financial and social impacts, particularly as they relate to sea level rise. High Tide on Main Street, Rising Sea Level and the Coming Coastal Crisis is his new book, and he'll tell us all about it now. So, John, welcome to Late Night in the Midlands. Pleasure to have you.
Thank you. Pleasure to be with you.
Well, I do thank you for taking time out to be with us tonight. Very important topic, no doubt about it. I thought maybe we could start out, tell us a little bit about your book and what's led up to you writing it, as if I have to ask. I mean, it's happening.
Sure, thank you. Let me put it in perspective, I guess. I started looking at sea level back 40 years ago, I hate to say, when I was in college, and I was fascinated that as the ice sheets came and went, what we call ice ages, and that's not in dispute at all, but that's something that I hadn't thought of, and hardly anybody else had except for specialists, is that as those ice sheets 2 miles thick came down over the northern hemisphere regularly in a natural cycle, that sea level went up and down 300 or 400 feet vertically as 10,000 feet of ice melted and then refroze every 100,000 years. And I thought that was amazing. The fact that we've had a fairly stable polar ice cap for 3 million years indicated that in our lifetimes nothing really would change. It was a very, very slow cycle. But then fast forward, of course, over the last decade or two, there have been increasing signs of warming, measurements of warming. And I started for the Maldives or the Bahamas or places like that as vulnerable to sea level rise, or Bangladesh, but nobody had ever thought about New York City, which was the reason that I wrote about it. And it has been an attention getter for everybody, and whether you live in the Northeast or anywhere else, because as I point out,
from Boston to Seattle to Vancouver to San Diego, to the Maldives, to Monaco, to Manila, to Shanghai, to Singapore. Every coastal city in the world has vulnerability. And then there are surprising vulnerabilities that people would never think of, like New York City, like Washington, D.C., which is on a tidal river, like Sacramento, which appears to be far inland but is on the Sacramento River and has 1,300 miles of earthen levees, more earthen levees than are in New Orleans. And actually, Sacramento has more vulnerability to earthen levees collapsing than New Orleans. So that was the purpose, to describe these dozens of places, which are literally hundreds of places in the world that people don't think of. They just think about Miami, the Bahamas, the Maldives, Kiribati, Tuvalu, the places they hear about. But this problem is truly ubiquitous. It's universal, whatever you want to say. It's all over the world. And the fact is that after 6,000 years of stability, which is how long sea level has barely changed, and that means the shoreline's barely moved, that after 6,000 years of stability, that we're in a new era, that we've crossed over, and now we're resuming the period when sea level will go up and down hundreds of feet, in this case up hundreds of feet, and eventually, and that could be thousands of years, but we started a new era and a new direction after 6,000 years of stability, and that's what's hard to get our heads around, that for the first time in 6,000 years, sea level's moving, the shoreline's moving, and it's going to continue for at least 1,000 years. That's what's hard to get our heads around.
Well, that is hard to get our heads around. What I found amazing about Sandy was two big storm systems that combined. I mean, it's the kind of thing I've seen in movies. You just never. I assumed that one day it would get that bad, but I didn't think so soon. And we should probably be preparing to see a lot more of this, huh?
Absolutely. Hurricanes, which of course what Sandy was, are driven by heat in the ocean. And if you think about it in climate or geologic terms, what a hurricane does is it moves excess heat from the tropics to the polar regions. It's driven by a heat differential, basically. And the oceans are 1.5 degrees Fahrenheit, 0.8 degrees Celsius, warmer than they were a century ago. And the rate of warming is accelerating. So with that extra heat stored in the oceans, and particularly in the surface layers, the top 700 meters, 2,000 feet, that heat is going to manifest itself in more stronger storms.
I see. Now, you believe, and I guess there's actually some scientific evidence to back it up, and I have no doubt that man is contributing, but you believe that man is what's putting the big impact on the change in the climate, correct?
Absolutely correct. And in fact, when I started writing this book, I used to say that man was accelerating climate change. As I did the research and put the case together and explain and show in a couple of simple diagrams, we've not actually changed or accelerated climate change or warming. We've changed the direction, and that's why we're in the new era. We have just finished. Well, let me back up. 20,000 years ago was the last glacial maximum, which we call commonly an ice age. And, the kids' movies are about it, and they have some accuracy to them, the Ice Age 1, 2, 3, and 4. But nobody disputes that we had an ice age during which we had 2 miles of ice down as far as New Jersey in the United States, and equidistant in Europe and Asia. And those 2-mile-thick ice sheets, again, they melt. But when you go back to that last peak 20,000 years ago, 21,000 years ago, when that much water was locked up in the ice sheets, the sea level was down 390 feet straight down from where it is today.
Wow.
That's a 30-story building. Now that it rose as the ice melted over 14,000 years and got up to pretty much its current level 6,000 years ago. Well, here's what became clear once I put that all out in charts
and did the timeline for myself is it became a really aha case of two things. That after 20,000 years of rise, by the cycle of the last 5 million years, to realize that we were altering the big picture, the natural cycle of ice ages. But I couldn't put it all together. And I had lots of different insights into the ocean from thousands of dives and even under the polar ice cap and working with leading scientists, but there were just pieces that didn't quite fit together. So about 4 years ago, I began to research everything I could so that I could fully understand what were the natural cycles and where were we affecting it, and what did it mean with sea level rise. And the book, as you say, is the outcome. It fortuitously was published a week before Sandy hit Atlantic City, and it was the most fortuitous timing, terrible as that event was, because in Chapter 12, as I think you know, I picked a couple of dozen cities to describe what could happen, and I described that kind of storm hitting Atlantic City and why it would devastate New York to show some peculiar factors of geology and topography that very few people have looked at. And the fact that it happened a week after my book was published was just pretty incredible.
That is incredible. Now, do you think that the Northeast has less skeptics now on this whole climate change issue?
I think so. I don't know where you're based. Are you up in the Northeast?
I'm in the Southeast. I'm in South Carolina, so
okay.
On the East Coast. But no, I just got missed. We were lucky. It hit I think the corner of South Carolina. Mostly went into North Carolina, so they got hit bad, but we didn't.
Yeah, I'm in Florida, and it was interesting. 2 days before it hit New York, or I guess a day and a half, it gave a good brush to Florida. They put enough sand over some of the main roads right along the coast to actually close some roads with the surf. But then it was only about a 30 or 40 mile an hour wind storm. By the time it hit New York, it was, I guess, 80 or 90 miles an hour and full Category 1. I think to answer your question that, yes, people in the Northeast are paying more attention, but they are all over the world, because the fact that you could have a 9.5-foot storm surge above normal tides and extreme tides, which is what we had then, was seasonal high tides, lunar high tides, that the fact that it could have that kind of a devastating effect because of certain factors, which is what I was describing in the book, has caught everybody's attention all over the world. I mean, people think of Miami, or we would be about to enter the 80,000-year cooling phase when the ice sheets would begin growing and sea level would begin dropping until the next ice age 80,000 years from now, give or take. Instead, we're warming, and the glaciers are shrinking all over the world, and sea levels rising. So we haven't just accelerated the change, we've actually broken or altered the ice age cycle, which has been on Earth for about 5 million years as a natural cycle. And when you look at it that way, when you realize that there is a natural cycle, it's a 100,000-year ice age cycle forced by something called the Milankovitch cycle, that when you just step back, and again, I try not to use technical terms, but when you look at this 100,000-year cycle of ups and downs, and we're at the top of it in terms of sea level, and realize it should be starting down, and it's now going up, and it will go up for at least 1,000 years, you realize we haven't accelerated climate change. We've changed the direction. And the numbers are...
Oh, I was just going to say, in 1,000 years, that'd be a huge, huge increase in the sea level if it continues to rise for 1,000 years.
It depends upon the rate. And there's a lot of unknowns in it, because we've never warmed this quickly. In 500 million years that we can go back and track, we've never warmed remotely close to the current rate of warming. So we really don't know how quickly the ice sheets are going to melt. I mean, that's absolutely true, that uncertainty. What we do know is that when all the ice sheets melt again, and that hasn't happened for 30 million years, that sea level will be 212 feet higher than it is now. But that's not going to happen likely for probably several thousand years. It takes a long time to melt 2 or 3 miles of ice, even with the heat we're applying.
Well, they have been melting rather quickly. According to a lot of the stuff that I've seen out there, it seems like I've seen an article not long ago that said Greenland had lost, I don't know, a large percentage of their ice, and that it was like green grass. So
yeah,
that's scary.
Let me say about Greenland. I was there in 2007 with a group, and it is melting quickly. And when you talk to locals in Greenland, in the 5 generations that the people I met with go back in Greenland, they've never seen anything like it. And that was 5-6 years ago, and it's melting faster today. I think the figure